Good morning and welcome to the Mono Lake area on the east side of the Sierras in California, looking down on the lake here on a beautiful, calm but chilly morning, looking south to some of the high Sierra peaks in the distance, and then wheeling around here towards the west as the sun just starts to catch the mountains here in the Sierras. Beautiful morning. Thanks for joining me this morning. I'm Geology Professor Shawn Willsey. We're at a place called Black Point, a volcano, the furthest north volcano in the Mono Inyo chain of volcanoes that extends north-south from the Long Valley Caldera north of Bishop up to this part of the Mono Lake area. And we're going to look at this volcano because it's pretty interesting and has some really cool things to show us, some surprises, I think. So what we're going to do here is we're going to talk for a second about this volcano, which sits just behind me here as the sun starts to rise. And then we're going to head up towards the summit and find some things that I think you'll find pretty interesting. Now, if you look at Black Point from an aerial view or Google Earth, it looks kind of flat. It looks a lot like what you might think a shield volcano would be in terms of its shape, its size, the steepness of its slope. And yet when we look at the ground here around Black Point, we don't see lava like we would expect at a shield volcano. Instead, what we see are little black rocks, almost what you'd call cinders to some respect. But this, of course, is not a cinder cone volcano either in terms of its size and shape. And so let's head up and look at this rock. As we look over here towards, I guess, the northwest, just starting to hit the light, we can see some layers of rock that have some very regular bedding to them, some layering in the rocks. So we need to figure out what happened with this volcano, exactly what kind of volcano it is, how it erupted, what its eruptive characteristics are. And then as we get near the summit, I think we'll see some interesting relationships and some other cool things as well. So let's head on up towards the summit here of Black Point here near Mono Lake. All right, we've come up maybe 150 feet or so vertically, and maybe, I don't know, less than a quarter mile away from where I last was talking to you. We've got a nice, great view of the lake here. Again, the view of the Sierras to the west. But now we're up here on outcrops of the volcano. And so let's take a minute and explore some of the rock characteristics we see here. And so we can see that the rock is mainly this tan or kind of beige colored material. We can see that pronounced layering that we saw off in the distance as well. You can see how well overall stratified or layered this is. We can also see there's these dark chunks of basalt embedded in the material as well. But most of it has this brownish hue to it. Most of the rock we see is this tan material. And if you've watched some of my other videos, we know what kind of volcano this is based on the color of this material and these dark particles in here. So rather than this being a typical volcano like a shield volcano or a cinder cone or a stratovolcano, we know that our volcanoes are erupting primarily basalt because that's mainly what we see here. And that's what makes Black Point a little different than some of the other volcanoes in the Mono Inyo chain. Most of them are felsic or silica-rich volcanoes that erupt rhyolite and obsidian and pumice. But ours here is a little bit different. It's mainly erupting basalt. And there's a few like this in this chain of craters that we see here. So the fact that we're seeing chunks of rock embedded together rather than lava itself suggests that the eruption was explosive, so it was throwing out material as it was erupting. We can get a sense for the energy of the eruption by looking at the largest particles. And so we've got a nice big football-sized chunk of basalt embedded here in the rock. This one has some little green olivine crystals in it too, it looks like. So we might be able to get a sense for the size of the eruption by looking at, again, the largest particles we see here. We also find in here pieces of other rock types embedded in here, not just basalt. Here's a piece of granite. And so you might be asking yourself, what is that doing in here? How's this volcano erupting chunks of granite? And if we move over here, there's another one right there, a golf ball size chunk of granite embedded in the material. So let's go back to the brown material. The brown stuff here is a alteration product we often see in basaltic volcanoes that erupt explosively when they're interacting with water, and it's called palagonite. So the story that's starting to develop here then, here's one more piece of the granite, and there's another little xenolith. So we've got this lake out here, Mono Lake. The age of this volcano is about 13,000 years, and 13,000 years ago was just at the end of the Pleistocene period when we had glaciers, big glaciers coming down out of the Sierras. And so Mono Lake, which is an enclosed basin that traps water, the snow melt and runoff from the Sierras, as well as whatever groundwater emerges, this lake was actually 5 times bigger, and it was a large freshwater lake called Lake Russell that existed at that time. And so Lake Russell was here when this Black Point volcano erupted. So the volcano's erupting under the water, and the lava is mixing with the water in the lake, flashing a lot of that to steam, erupting quite explosively, and producing what we would call a phreatomagmatic eruption or a hydrovolcanic eruption, water and magma mixing together. So that eruption is blowing out chunks of lava. So that's the dark rocks we see embedded in the palagonite and the ash. And then we also see chunks of granite, and the presence of the granite here suggests that these are all pieces of the rock beneath us, the Sierra Nevada batholith. The granitic rocks that we find out here in the Sierras also exist here beneath Black Point, and some of those pieces of granite were being incorporated in the eruption, blasted out of the vent as the volcano was erupting, and were incorporated and included in the tuff, in this palagonite rich tuff. So this is mainly pieces of ash particles, but they've been altered. That's why they're this more brown color. Pieces of the original lava, which is the basalt, the dark material, and then pieces of the granite that we've seen in here as well. Pretty remarkable. What also is amazing about Black Point, and why I brought you to this specific location, is this part of the volcano has these amazing fractures that run along parts of its summit. These cracks in the volcano itself that run through the volcano. And these are maybe up to like 30 feet deep or so. We're gonna go through one here in a second. We'll go down to the bottom end and walk through this. But it's basically like a slot canyon, if you will, if you've seen those in southern Utah, cutting right through the material. Now, because we have a volcano and now we have this big crack in the ground, a fissure, you might be thinking, well, this is a vent. This is where the volcano erupted. But we really don't see any evidence for that. We don't see the types of material or textures that you might see at an eruptive fissure. There's nothing to suggest that any of the materials blasted out of the ground here. This appears to be a crack in the ground, a fissure that formed after this volcano had formed. So let's see if we can head down into this thing and make some observations, and then hopefully piece this whole story together. We'll walk down here to the western end, and I think we can walk right up this thing. Okay, so here we are at the west end of this fissure, and it's just wide enough to walk through. Right away I can see that it has some, almost like the sides of it are somewhat plainer. They're also coated in white, which is something I think we'll come back to here in a minute. So in places I've actually got to turn a bit sideways, but I'm hoping that not only is this kind of fun just to walk through, but it also provides great exposures of the eruptive material of this tuff, the xenoliths, the ash, and so we can make some good observations in here as well. Kind of drops down, gets a little deeper here. And I think this is probably as good a place as any to look at this coating that we see on the walls here. One look down the way there. It appears that this coating, whatever's coating the walls here, not only is it light colored, but it's somewhat harder than the rock around it. We can see the rock back here is recessed, and then where this stuff occurs, it's forming a more resistant weathering surface here. So, and here's actually where we can see almost like, it looks like almost like drip features coming down parts of it. Pretty cool. What this may be, and we'll have to test this here, is remember we have the lake, and the lake was much bigger. So this volcano erupts beneath ancient Lake Russell, and then Mono Lake would come into existence. You know, it's the same lake essentially, but at some point the lake is shrinking, the glaciers are melting, the runoff and the amount of water in this region is declining, but the chemistry of the water probably largely stayed the same. And Mono Lake's known for its fabulous tufa towers along some of its shorelines. And so as a suspicion here, this may actually be calcium carbonate. Yeah, so we're getting a nice reaction with the acid there. So these are just calcite deposits across this fractured surface. So when this fracture formed, possibly it was still underwater. Yeah, it was underwater, and so the calcite was deposited on the surface of the fracture. And since that time, weathering has eroded away some of this calcite or tufa deposition on the fractures, and that's why we have these parts like right here where it's cut through some of those. So let's head back down a little further. So we're seeing good evidence of the lake really occupying this area for most of what we see here's existence, for both the volcanic eruption and whenever this crack occurred in the volcano. This is just pretty awesome. I mean, it's perfect width you can walk through. My shoulders aren't rubbing on either side. Nice and flat bottomed, very accessible. And it looks like we have a little rock fall hazard up ahead where we got to climb up and over. Looking up and over, and then back down this way. Trying to give you some perspective here. And so let's get up and over this thing, but also talk a bit about the volcano. So the volcano erupts below Lake Russell, which was the predecessor of the ancestral Mono Lake, I suppose. And you know, this volcano is erupting, it's erupting explosively, and then at some point we would have the wave action. So why did this thing not form? Why did this volcano not form a classic, like a tuff cone or a tuff ring or some of the hydrovolcanic structures that we are familiar with? Well, this lake's large enough, and possibly the wind and the wave action is enough that it's constantly modifying and flattening it out a little bit. And so it's very probable that the shape of Black Point exists because of the wave activity on the volcano as it was trying to form. So the volcano was trying its hardest to make a good, respectable volcano, but the wind and the waves on the lake were inhibiting that, and so you end up with this sort of flattened volcano without the shape that we might expect otherwise. One hypothesis for these fractures, these cracks that we see on this part of Black Point, is that the material became pretty saturated beneath the water, and part of the volcano actually slid and moved. So it actually failed and slid outwards opening up some of these cracks at the top. That may be true. If you look on Google Earth, though, you'll see that some of these cracks, they have some like odd and intricate patterns. They intersect each other. There doesn't seem to be much rhyme or reason to them, but pretty interesting. Bit of an obstacle here. I guess we could see if we could go a little further. I'm going to go ahead and shut the camera down and see if we can get through this little section, and then we'll film a little bit more. Okay, so I was able to scramble down the block there that had fallen. I needed both hands, so sorry to cut you off there. But now we're back into a little section that looks much easier to navigate. But you can see, yeah, like here's this little secondary fracture coming off of this one. And there's this one here. These don't show any signs, unlike slot canyons in southern Utah, which formed by water moving through them and water-driven erosion. I think it's fairly flat up here, and while the water certainly probably gets channeled into these, there's really no evidence that the water really moves through here, like it's really a canyon, if you will. So it looks like now it's opening up a bit. We'll go a little further, maybe actually scramble up top here and get one last look around, see if there's anything else we can point out. But yeah, these cracks or fissures provide great exposures of some of the layers. Like for example, here we can see larger chunks of lava or basalt pieces that were thrown out, and then it gets a little more fine grained. And so these changes in sizes represent changes and fluctuations in the energy level. You can almost think of this volcano as somewhat pulsating at times. So it's got a little more energy, throwing out bigger particles of lava that cool quickly, and then smaller particles when it's a little less vigorous. And then you can see that alternating as you go up. So let's scramble up this little crack here and see what awaits us up on the rim. Oh, the sun, that's what awaits us. Yeah, great view of the mountains. It looks like the fracture we're in goes a little bit further, but mainly flattens out over here. And the true summit of the volcanoes looks like just over here of Black Point. But this is a great place to come if you are in the area. It's pretty accessible, probably a half-mile walk up a hill, but it's not very steep. You can walk right into some of these fissures and explore them on your own. The granite xenoliths are pretty readily observed anywhere you look at the plagonite tuff, and you'll see there's one over here, little white chunks, white and black salt and pepper looking chunks in the rocks themselves. So let's do one last view of Mono Lake, and then we'll call it good here. Beautiful morning. You might be able to see, they're quite a ways away, but on the far side of the lake, there's some white tufa towers sticking out of the lake. And then at the south end, there's some really nice ones you can access as well. So no end to the number of cool geologic features you can explore and take in here in this part of the Sierra. So thanks for joining me, friends. Hope you learned a few things. Thanks for enjoying and exploring Black Point with me here near Mono Lake. This is one of my favorite places to come. Just world-class geology all around. Please be sure to like, share, subscribe, and also if you'd wish to donate and help me get out and make more of these videos, and you know, for the cause, you can do that by the thanks button in the bottom right of the viewer, and then also there's a PayPal link under the video description. So until next time, we'll go ahead and sign off from the amazing fissures of Black Point, the hydrovolcanic and phreatomagmatic rocks, if that's your fun new word for the day, and just the majesty of Mono Lake and the Sierra Nevadas of California.